Hey, let's check out some practice problems for how to calculate protons, neutrons, and electrons within one atom of an element. So looking at your practice assignment, what we've got going on is a column for all particles. We've got protons, which of course are our positive particle. We have electrons, which are our negative, and neutrons, which are our neutral particle. And what we need to do is for a couple elements here, like strontium or iodine, we're going to calculate a few things. First, we're going to figure out the number of each of the particles, and I'll give you a little hint reminder on how to do that. And then we're also going to calculate period and group. I guess not calculate, but find it on the periodic table. So sometimes the hardest thing is simply finding it on the periodic table, and once we do find it, we're able to then go through the steps. So real quick, let's go through our hints. First thing and easiest to calculate is our protons, our positive particle, and what we need to do here is just look at the periodic table. So when we locate strontium on the periodic table, we see that it has two numbers, 38 and 87.62. Now one of those numbers directly tells me how many protons, and from our practice we know that is the atomic number. And again, reminder, the atomic number is the whole number on the periodic table. So you can go ahead and make yourself a little note there. Atomic number, which is the whole number on the periodic table. And so for strontium, we can record 38. Next is electrons, and electrons being the negative particle, we're going to notice are always going to equal out to the protons, and this is why. For an atom, our protons will always equal our electrons because an atom's charge is neutral, and so we need those two to cancel each other out. Positive equals the negative. So electrons will always equal our protons, and again, I like to write my little reminder here. I also use that same atomic number, which for strontium was 38. Our last one is neutrons. Neutrons are our neutral particle, and this one is not found on the periodic table. A lot of times we want to take that decimal that we see, that 87.62. And we have to remember we can't have 0.62 of a particle. We have to have a full particle, so we can't use that decimal ever. What we need to use is something known as the mass number. And here's what's a little bit tricky, is the mass number is not on the periodic table. What the mass number is telling me is which isotope I'm using. And so whenever we have a problem like this, I'm always going to give it to you. So if you look back on your worksheet, right underneath where it says strontium, we see the mass number given there, which in this case is 87. So I need to then take that mass number, 87, and I'm going to subtract from it the atomic number, which happens to be the same number as the protons. So I'm going to take 87 minus the number we've been using, 38, and when I do my math, I'm going to come out with 49 neutrons for this one atom of strontium. So quick little recap of our hints. Protons, atomic number, we found that as the whole number on the periodic table. That was 38. We know electrons will always be equal to our protons. Those two have to balance each other out. So we also see electrons as 38. And finally, our neutrons, we do a little calculation. We take the mass number, which is given. And again, that's for a specific isotope. So we might have another problem of strontium later where we're looking at strontium 93 or 72. Just depends on what version of that atom we have. For this particular problem, we're looking at strontium 87. So we take that minus our number we've been using for protons to come out with 49. Perfect. Let's try the next one together here. Iodine. Find that on your periodic table. It looks like this. Capital I, iodine, there it is. Again, it has two numbers, one whole number and one decimal. One of those is my number of protons. So if I look back up at my hints, I'm reminded it is the whole number. So there are 53 protons in this iodine, in every single iodine atom. We know that the protons in an atom will always equal my electrons to keep the particle neutral. So I have two 53s. And then my calculation, I've got to use my mass number here, which is 127 minus 53. And when we do a calculation of that, we'll have our number of neutrons. I'll let you do that on your own. Now once you go through, don't forget to check out your period and your group. Remember, period goes across. So wherever you find iodine, follow it across and check out the number on the side. That would be period 5. Groups go up and down. Again, wherever you find iodine, trace it up, and that would give you group 7. Let's do one more. Last one here, let's check out sulfur. Protons we know is directly connected to our whole number on the periodic table. That would be 16. And again, if I have 16 protons, I've got to have 16 electrons. The positive and the negative cancel each other out to keep the atom neutral. And finally, my neutrons. Remember, I check out my mass number, which is 32, and I subtract my number of protons to get me neutrons. Period. I check out the periodic table going across, and I check out the group by going up and down. Okay, so again, the hardest part about this is trying to find the element sometimes. Find it, calculate, shoot me a note if you get stuck. Last one. I'm asking you down here at the bottom to check out all the ones you just did, so numbers 1 through 10, and see if you can figure out which two are isotopes of each other. Check back at your definition of isotope and just search the list and see if you can put a star next to the two that would be isotopes. Great work.